Welcome to M for Mathematics. This is Kamal. Today in this video you will be studying about trigonometry. Actually this video is specifically for grade 10 CBSE because some of the students are requested for this video. So I'm just going to cover that syllabus in this video. So it will be a series of videos. So I'm going to cover the complete topic of trigonometry in this series. So we'll start with the very basic thing. What is trigonometry? Okay, I'm starting with some examples from the surroundings. So if suppose there's a building, AB is in a building and there is one observer at point O. This observer is looking at this highest point of the building. So his eyes are making some angle. Okay, this is one example. One more example. Now observer is at the top of a building. Okay. And this observer is looking at one car which is lying on the ground. So he is looking downwards. So in both the examples, we can use some mathematical techniques to find this distance or this height we can find. Same here, we can find this height, we can find this distance by using some mathematical techniques. And those mathematical techniques comes under the branch of mathematics which is known as the trigonometry. Actually, trigonometry is the study of relationships between the sides and the angles of a triangle. So in this triangle, like in this triangle, we can relate these sides and angles together. So that branch of mathematics is known as a trigonometry, in which we use relationships between the sides and the angles of a triangle. Okay, so if you look at both the examples, what kind of triangle we have? Both are right angle triangles. So we'll start our trigonometry with one more right angle triangle. I'm giving it a name, say PQR. Okay, it's right angle at Q. This angle is 90 degree and this is say R. First of all, just you need to make one thing clear. If suppose this is my angle of consideration, okay, I am using this angle R and I'm giving it a name, say theta. Theta is the Greek letter. Theta. It's a Greek letter. And we give this symbol to angles. Okay. So if we are considering this angle as theta, then the side opposite to this angle theta, that is PQ. So this is known as the opposite side. Or in some books it is given as perpendicular. And this one QR is known as the adjacent side, adjacent to this angle theta. Or in some books it is used as a base. And the side opposite to this 90 degree angle, which is the greatest side of the triangle, that is PR, is known as the hypotenuse. So now we have these three sides. This is perpendicular, this is base, this is hypotenuse, or you can term them as this is opposite side, opposite to this angle theta, adjacent side, adjacent to this theta, and this is hypotenuse only. Now if we change our angle of consideration, like this is triangle ABC, right angle at B, and if suppose this angle is theta, then this will become the opposite side, this will become adjacent, or you can say base, and this will remain your hypotenuse. Okay, so now we'll move to some ratios of the sides of a right angle triangle with respect to its acute angles, which are known as trigonometric ratios. So we have one right angle triangle, so PQR, right angle at Q. I'm giving this angle R a name theta. Now we have these three sides, so I'm giving it a name hypotenuse. This is opposite to theta, so I'm giving it a name opposite side, and this is the adjacent side. So I'm giving these names because I'll give you one very easy way to remember all the ratios. Okay, so we'll start with, now look at all three sides. So we have three sides, so we can give 6 ratios out of these. How 6 ratios will be there? So I'm starting with the very first one. Say I'm relating these two sides, opposite and hypotenuse. It's a 1 ratio between opposite side and the hypotenuse. Okay. Then next, adjacent upon hypotenuse, right? And the next one, opposite upon adjacent. So first we will discuss these 3 ratios. Number 1, number 2, number 3. So what is opposite upon hypotenuse? Opposite is this side and this is hypotenuse. So what is opposite? PQ upon HR, sorry, PR. This is perpendicular, this is hypotenuse. So we'll give this ratio a name sin theta. What is adjacent? Adjacent is QR upon, what is hypotenuse? Hypotenuse is PR again. We'll give this ratio a name cos theta. Opposite upon adjacent. Opposite is PQ upon adjacent is QR. So PQ upon QR, we're giving this a name tan theta. These are our 3 basic trigonometric ratios: sin theta, cos theta and tan theta. Now, if you look at these ratios, we can form 3 more ratios just by reciprocating them. Like from first ratio we have opposite upon hypotenuse, we can make one more ratio which is hypotenuse upon opposite, right? The next one will be hypotenuse upon adjacent, and the third one will be adjacent upon opposite. So these are 3 new ratios and they are reciprocal of these. So sin theta was opposite upon hypotenuse, its reciprocal is given a name cosec theta. Then hypotenuse upon adjacent. Adjacent upon hypotenuse was cos theta, its reciprocal is given name sec theta. Opposite upon adjacent was tan theta, its reciprocal, that is adjacent upon opposite, is cot theta. So in all we have 6 trigonometric ratios: sin theta, cos theta, tan theta, their reciprocals cosec theta, sec theta and tan theta, sorry, cot theta. Now we have these 6 trigonometric ratios: sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta. So cot is reciprocal of tan theta, so we can write it as tan theta is equals to reciprocal of cot, that is 1 upon cot theta. Similarly, cos is a reciprocal of sec theta. If you look at the relation, cos and sec are reciprocal of each other, so it means cos theta can be written as 1 upon sec theta. And finally, sine is reciprocal of cosec theta. Okay. Now, one very important thing, we can derive one more relation between sine, cos and tan. If you look at these three relations, tan is PQ upon QR. If we divide these two relations of sine theta and cos theta, I'm dividing these two relations, so these are PQ upon PR. I'm dividing these two relations, PQ upon PR, QR upon PR. So this PR and PR will be cancelled out. It will become PQ upon QR. So what was that? PQ upon PR was your sine theta upon, what is QR upon PR? It was cos theta. And what is PQ upon QR? PQ upon QR is tan theta. So it means sine theta upon cos theta is nothing but tan theta. So very important relation. In the similar manner, we can have one more relation, that is, as we know that cot theta is reciprocal of tan theta, so just reciprocate it, so it will become cos theta upon sin theta. This is cot theta. Okay, now very important part. Every time we are writing it as sin theta, so it is not a product of sine and theta. Just remember this. It is not a product of sine and theta. It is just sine theta. And without theta, sine is meaningless. If we are just writing sine, the sine is meaningless. Right? Whenever you have to write sine, just put some angle with that. Without angle, sine is meaningless. And it is not a product of sine and theta. It is just sine theta. So far we have studied about the trigonometric ratios. Now we know that sine theta is opposite upon hypotenuse, cos theta adjacent upon hypotenuse, tan theta opposite upon adjacent. Now I am giving you one trick to remember all these three ratios in a very easy way. For sine I am using S. What is the ratio of sine? Opposite upon hypotenuse. So it is SOH. Just read it like so. Then for cos it is, I am considering C, adjacent and hypotenuse is AH. So ka. For tan, just T, and opposite and adjacent OA. So ka toa will give you all these three relations. For sine, opposite upon hypotenuse. For cos, adjacent upon hypotenuse. For tan, opposite upon adjacent. So just remember, so ka toa. Okay? So it's a trick to remember all these three ratios, and others you can derive with the help of these, because we know that cosec is reciprocal of sine, sec is reciprocal of cos, and cot is reciprocal of tan. Now just look at these two relations. I'm just drawing one right angle triangle. So this is 90. This angle is theta. Okay. Now sine theta is opposite upon hypotenuse. We all know that hypotenuse is the largest side in a right angle triangle. And if you look at these two ratios, in both we have hypotenuse in the denominator. So it means every time we are going to have a larger denominator. So when we have a larger denominator, it means we are comparing with the numerator, right? Denominator is larger than the numerator, then this ratio is always less than 1. So in both the cases, for sine as well as cos, these values will be always less than 1. So sine theta and cos theta, they always have values less than or equal to 1, you can say. It is never more than 1. Never greater than 1. Okay? Remember this part. It's very important result for sine and cos. They will always have values less than or equal to 1. Okay? So we can write for them that sine theta is always less than equals to 1, and similarly for cos theta is always less than equals to 1. So I'll take one example. We have one triangle ABC. This angle is theta, and we have given that sine theta is equals to 1 by 3, and question is asked to find all the trigonometric ratios. How to do this now? If you look at sine theta is equals to 1 by 3, what is sine theta? If you look at this figure, sine theta is opposite upon hypotenuse, so it is AB upon AC as 1 by 3. Now it's a very common mistake that students are considering this AB as 1 and AC as 3, which is perfectly wrong. Okay? So because as it is a ratio, so we cannot have these values, that AB cannot be 1, AC is not 3. Okay? So these are the ratios. So what we are going to do, we'll consider, let AB is 1K, K is any positive number, and AC is 3K. So now AB is 1K, AC is 3K. Now it's a right angle triangle, we can apply Pythagoras theorem in that. Okay, so we will find this BC. So how to find BC? By using Pythagoras. BC square is equals to AC square minus AB square. This is clear? BC square is equals to AC square minus AB square. What is AC square? AC is 3K. Minus, what is AB? AB is 1K. So it will become BC square is equals to, it is 9K square minus 1K square, which is 8K square. So BC will be square root of 8K square. As it's a length, so it cannot be negative, so it will be 2 under root 2K. This is your BC. So now we have all the three sides of a triangle, so we can find all the trigonometric ratios. So I am calculating it one by one. What is cos theta? Cos theta is adjacent upon hypotenuse, so it is BC upon AC. What is BC? BC is 2 root 2 K upon 3K. Next is tan theta. What is tan theta? Opposite upon adjacent, that is AB upon BC. What is AB? AB is 1K upon, what is BC? You can cancel this K and K, this K and K here, right? Then cot theta is nothing but reciprocal of tan theta, so it will become 2 root 2 upon 1. Sec theta is reciprocal of cos, so it will be 3 upon 2 root 2. And cosec is reciprocal of sine, so sine was 1 by 3, so it will become 3 by 1. So this is how we are going to calculate all the 6 trigonometric ratios. One more example. If cot theta is 7 by 8, this is given, evaluate this expression. Value of this expression is asked to find, and value of cot square theta. So I am starting with this. Cot theta is given as 7 by 8. So I am drawing one right angle triangle, ABC, considering this as theta. Now cot theta is given as 7 by 8. What is cot theta? Cot theta is base, that is BC, upon or adjacent upon opposite, reciprocal of tan theta. Adjacent, so this is 7, so I am considering it as 7k. Adjacent upon opposite, this is 8k. Right? So by using Pythagoras theorem, we can calculate this AC as AC square is equals to AB square plus BC square. What is AB square? It is 8k square. What is BC square? 7k square. 64. 49. Right? What is 64 plus 49? This is 113 k square. Right? So this is your AC square. So what is your AC? AC will be square root of 113k square. Or we can just write it as square root of 113k. So this is your AC. Now we have sine theta and cos theta. So just calculate what is your sine theta from the figure. Sine theta, this is root of 113k. What is sine theta? Opposite upon hypotenuse. 8 upon root 113k. K will be cancelled out. Similarly, cos theta. What is cos theta? Cos theta is adjacent upon hypotenuse, so it's 7 upon root 113. Now, moving to this first part. 1 plus sine theta into 1 minus sine theta. If you remember, this is a plus b and a minus b. This is a square minus b square. So it will become 1 square minus sine square theta. Similarly, in the denominator, it is 1 plus cos theta into 1 minus cos theta. Again, use the same identity, a plus b into a minus b. So it will become a square minus b square is 1 square minus cos square theta. Now, how to find sine square theta and cos square theta? What it means? Sine square theta is nothing but sine theta whole square. And what is your sine theta? Is 8 upon under root 113. Similarly, cos square theta is cos theta whole square. So I am going to use these expressions in place of this. So it will become 1 square is 1 minus. What is sine square theta? Sine square theta is sine theta whole square. So sine theta is 8 upon this. So it is 8 upon root 113 whole square upon 1 minus. Now what is cos theta? Cos theta is 7 upon root 113. So it is 7 upon root 113 whole square. And solving it, you will get 113 minus 64 upon 113 minus 49. I hope I skipped one step because of the space. So it will become 49 upon 64. Now move to the second part, which is to evaluate cot square theta. Now what do you mean by cot square theta? Cot square theta is square of cot theta. Now value of cot theta is given, that is 7 upon 8. We'll square it, it will become 49 upon 64. So this is the answer. So I hope it will give you some clarity about how to find the values of trigonometric ratios. If some value is given, we can use this. We can apply Pythagoras theorem to calculate the remaining third side. Like in this case, 2 sides are given, or ratio of 2 sides are given. So we can find the third side by using the Pythagoras theorem. And we can find the values of other trigonometric ratios. So this is all about how to find values of trigonometric ratios. I hope this is clear. Thank you.